This assessment asks us to draw the reaction coordinate diagram for the acid-catalyzed aldol reaction, highlighting the steps shown in Table 20.1. I've shown those steps here, Step 1, Step 2, Step 3, and Step 4. The reaction coordinate diagram that we're going to show is only going to be for Step 1, Step 3, and Step 4. The reason for that is that this aldehyde gets protonated to join this overall reaction, so we won't show it in the reaction coordinate diagram. However, we will recognize that protonating this aldehyde is an uphill reaction, and that's going to be important for us as we get into the reaction coordinate diagram for what's shown in green. We'll start with Step 1. Formation of an enol is a two-step pathway. We'll just show it as one. We know that the enol is less stable than the ketone, than the aldehyde, so this is going to be an uphill first step. So Step 1, formation of the enol is uphill. At this point, the enol is going to react with a protonated aldehyde in a reaction where two molecules become one. So delta S is going to be less than 0 for this reaction and therefore unfavorable by entropy. But the bonds that we form are going to make up for that. The bonds formed versus the bonds broken are going to make up for that so that delta H is less than 0. Essentially, that's going to make this one have delta G right around 0. So no real change as we go from here to here in Step 3. We said at the beginning that protonating the aldehyde was an uphill step. It should make sense then that deprotonating the aldehyde should be a big downhill step. And so Step 4 is going to bring us down to here. And now if you notice, I've intentionally had this reaction finish below where we started because we know this reaction is a favorable reaction, and it's favorable by this value here. So it's an overall favorable reaction. These are the three steps we would show in the reaction coordinate diagram.